I will now demonstrate a response surface model of SimHerd. A response surface model, or RSM, is a set of regression models that describes the output of the complex SimHerd model as a function of the input. So, an RSM is a proxy of the complex model, while easier and faster to use. So now a demonstration of this dashboard, which is the interface of the RSM. The blue numbers on the left represent the Herd's key figures today. With the pluses and the minuses, we can specify how much we wish to improve these key figures. The red numbers in the bottom represent the changes as a result of improving the key figures. So the red numbers are the output and they are a function of the input. And this function or equation is what we call the response surface model. Let's now change the calving interval with 10. We see that this results in an increase in milk yield, but also an increase in cow mortality. So this dashboard encompasses a typical element that we also find in the complex SimHerd model. When improving reproductive performance, we get more calvings in the herd. And the period around calving is a high risk for cow mortality. So when only improving reproduction and nothing else, the incidence of cow mortality will increase. Replacement rate decreases because we assume that the improving reproduction reduces the number of cows culled due to not being pregnant. The lower replacement rate results in a higher surplus of heifers that we can sell every year. And in the bottom here we see the overall economic result, which is an increase in net return of 46 euros per cow and year in the herd. So basically, if you have a 100 cow herd, you can put 2 zeros behind this number, meaning that the increase in total net return is 4,600 euros in a 100 cow herd. I will now demonstrate the element of diminishing returns, which is also present in this dashboard. If we change the today situation for calving interval from 412 to 400, the same change in calving interval of 10 days now has a much lower value. Net return increased with 46 before, and now it's only 27. This law of diminishing returns is something we typically see in the complex SimHerd model, but it is also demonstrated in this dashboard by the response surface model. Let's click on Reset. Now we reduce mastitis from 22 to 11. Milk yield, cow mortality and replacement rate change as a result of this, and the overall increase in net return is 44 euros per cow per year. If we now change the herd level milk yield from 10 to 12,000, which basically means that we're performing the same comparison, low versus high risk of mastitis, but now for a high yielding herd, now we see that the increase in net return is not 44 but 49 euros per cow per year. If we furthermore increase milk price in this herd or in this country, for example, we see that the net return increases from 49 to 54 euros. Of course, we can change several key figures at a time. Due to the presence of interaction terms in the response surface model, we ensure that the effects are not simply additives. A little peek on this sheet, RSM, of the model. On this sheet, all the regression models are hidden. So this sheet is basically the engine of the model. These are the regression models that describe the output of SimHerd as a function of the input. The regression models are built using thousands of different simulations of the complex SimHerd model. And these many simulations have been chosen intelligently, allowing to use these regression models for interpolation and extrapolation. Here, for example, the regression model that describes the increase in energy corrected milk per cow year as a function of the input. The model shows, for example, that milk yield per cow year decreases with 260 for every case of mastitis. Additionally, this interaction term, yield times mastitis of -18, shows that in case of mastitis and a very high milk yield potential in the herd, the decrease in milk yield is even higher. These coefficients are difficult to interpret, but you can see the interactions. And these regression models are not used to interpret the single coefficients, but the regression models, the purpose of them is to predict. And prediction is what they do very well. This model, for example, has an R-square around 0.97, which means that this regression model predicts energy corrected milk very well as a function of the input. And that's basically what we do with these regression models. Now we go back to the dashboard, which is also where our demonstration stops. So this is basically a demonstration of what can be done with the response surface model. Also, the layout of this dashboard is a draft and typically used by our customers to validate and play around with the model. Instead of using this dashboard, the response surface model is typically incorporated in the customer's own platform or management software.